Rise and shine, porcupines. It's Algebra with Al time, and I'm your host. You know my name, Al Rosetti. So today we're looking at Chapter 5, Unit 5, Solving Polynomial Equations. So after watching this video, students will be able to solve polynomial equations. The concept is polynomial equations. The skill, solving. So I'm excited. Why don't we get started? Well, here we go. All right, so to get started here, we're looking at number 1. And they want us to factor. Now remember, what factoring is a form of division. Whatever we can multiply in, we can divide out. And so that's what factoring is. Taking something they both have in common and dividing them out. So look at number 1. What do they both have in common? Well, we can divide a 7 from both and what? An x from both. And what we're left with is x minus 2. So that is factoring. Okay, that's what they mean by factoring. Taking something out. If we multiplied it back in, you have the same original answer, and that's what you should have. All right, looking at number 2, obviously we can divide 19 out of both terms. And then remember, when you're doing the exponents, you want to take as many as you can. As many exponents as you can out, but it has to be even. So since there's x squared on one and x cubed on the other, you can take out 2 from each. If you do it correctly, one of the terms should not have any more variables left when you're done. Okay, and so when we take out 19x squared, what are we left with? Well, we're left with x, and then we're left with 2. And that's how you want to write it. Take what you're dividing out in front of your parentheses, and what's left over goes inside a parenthesis. All right, number 3. So now you have to have something to divide out of all 3, or it's not a common factor. It's not a GCF. All 3 have to be divisible, by the same number. And you want the largest. So if you do this and you see that all 3 terms still have something you can divide out, well then you got to do that. Okay? We want the largest number you can divide out of all 3. We want to minimize the work we have ahead of us. Okay, so what are we going to divide out of all 3? We can divide 3 out of all 3 terms. We're left with 7, -6, and 8. Now what about the variables? Remember what I said, we want the largest amount that we can. Now, not all of them have y's. So we can't do anything with the y's, but we can take out what? We have an x to the first, x squared, x cubed. Remember, we have to take the same amount out of all. So the most we can take out is one of the x's from each term. So we're going to divide out 3x. That's our GCF. It goes outside the parentheses. And we're left with 7x squared minus 6xy plus 8y. There you go. So GCF was 3x squared. All right, number 4. 8j to the third power k minus 4jk cubed minus 7. Now, ask yourself, do all 3 terms, let's separate the variables for a second, do all 3 terms have some number you can divide out of all 3 evenly with not having any remainder, no fractions? And that would be no. Now look at the variables. Do all of them have the variables? And that answer would be no. So that one is not factorable. It's already prime. Okay, looking at number 5. What's it want us to do here? Solving polynomial equations. We're going to factor this. Remember how to factor a trinomial. We always want to take a look and see if c, which is -18, right? If you can come up with a set of numbers that multiply together to equal that and add together to equal 7. And you can. 9 times 2, right? Or 9 times -2 is -18. And 9 plus -2 is positive 7. So it equals the b term. So those are our factors. Put them in factor form. You have a plus 9 and a minus 2. All right, number 6. 2ak minus 6a plus k minus 3. Now this is you got 4 terms. We're going to factor this by grouping. Okay? We're going to take the first set, the 2ak minus 6a. We're going to group that. What can we take out of there? We can take a 2a out, right? And we're left with k minus 3. Now, since we have the same term left there, k minus 3, well then we already have our factors. We divided k minus 3 by 1, and we have 2a plus 1 times k minus 3, and that will give you 2ak minus 6a plus k minus 3. So that's factoring by grouping. All right, number 7. Is there a value, is there 2 numbers that multiply together to 7 that equal 8? Well, yeah, 7 times 1 and 7 plus 1. So we know those are our factors because the factors have to multiply to C and add to B, and B is 8. So B plus 7, B plus 1. Put it in factored form, you're done. Last one, number 8. We have Z squared minus 8Z minus 10. All right, is there a value, is there two numbers multiplied together that factor, factors of 10 that add to negative 8? And that would be what? No, there are no factors that multiply to negative 10 and add to negative 8. So guess what? This one is not factorable. Think about it. 10 and 1, right? And 5 and 2. There's no way to make any of those equal to 8 or negative 8. So this one is what we call prime. All right, so there's the answers for number 9, 10, and 11, and 12. And we're going to start on 13. Now we're talking, you see they're not squares anymore. Those are cubes up there. And we have what we call the difference of cubes. And it's a formula. You see it up there. A cubed minus B cubed, which we have, n to the third power, and negative 125 is a cube, is going to be equal to A minus B, right? So A would be n and B would be 5. So n minus 5, right? And then you're going to have A squared, in this case that would be n squared. You're going to use the opposite sign of what the problem is, and the problem is a minus sign, so your first sign is going to be addition. So it's going to be n squared, right? Plus, you're going to use the opposite sign like I said. Then it's going to be 5n, and then the last one is going to be the b squared, right? B is 5, 5 squared is 25. So there you go. It's a formula that if you can remember, there's really nothing to writing out the factors. So at number 14, we have m to the fourth minus 1. Now, you should recognize that as a difference of two squares, right? So m to the fourth, the square root of 4 is 2, right? So it's a difference of two squares. Make sure you understand difference means subtraction, okay? Not plus. So if it's a difference of two squares, you should know the pattern, right? So what's the pattern? M squared, right? Plus 1, and for the middle term not to be there, the signs have to be opposite. So if there's no middle term, the signs, they can be the exact same polynomials, opposite terms. That's the only way you can get rid of the middle term, and it's got to be 0, right? So here we go. Now, m squared minus 1, that's the difference of two squares, right? And so your factors are m squared plus 1, that's the prime, and then we have m minus 1, m plus 1. Remember, same exact polynomials, different signs are the only way the middle term would be missing. All right, we're on 15 now, right? So write each expression in quadratic form. Now, pay attention, please. This may seem a little strange, and I might even have to pause this video to explain it. But look at the b term, x squared. Can I take x squared, raise it to the second power, and have it equal the first term? And it does. X squared squared is x to the fourth. So I can write this one in quadratic form. The x squared is your x now. Okay, it's like we factored it out. So it's 5x squared to the second power because the quadratic's first term is squared. The second term is x squared to the first power because the second term in a quadratic is just x to the first. There it is. And the constant is last. So that is quadratic form. Now look at number 16. Can I take y squared and square it and have it equal y to the eighth? Well, no, you can't do that. It doesn't equal that. You can take y squared to the fourth power and equal to the eighth, but not squared. It has to be a squared term. So number 16 cannot be written in quadratic form. You have to look at the b. The most you got to work with is whatever the b value is, and b is y squared. And there's no way to use y squared and square it and have it equal y to the eighth. So not possible. All right, 17a to the sixth plus a to the third. Can I take a to the third, put it in parentheses, and square it? Will it equal a to the sixth? And the answer is yes. So this one we can do. It would be a cubed raised to the second power, that's quadratic form, right? And then the next one would just be a cubed to the first power. So the answer would be 100a cubed raised to the second power plus a cubed raised to the first power, and that is standard form, quadratic form. You don't have to have the constant. I mean, it doesn't have to be there. As long as this is in standard form, it's fine. All right, 18. Can you take the b term, 4x to the fourth? Can you take the x to the fourth, right, here, and raise it to where can you take 4x to the fourth, right, the x to the fourth, put it in parentheses and square it and have it equal x to the eighth? Well, the answer is yes, that does equal x to the eighth. So this we can put in quadratic form. So the x to the fourth squared, then the next one before x to the fourth raised to the first power basically, plus 9, that's quadratic form. All right, there's your answers to 19 and 20. 19 and 20 is not possible. All right, let's go to 21. Now we're going to solve these equations. And remember our steps when we're solving anything. Can you take out a GCF? Always look to simplify the problem first. Okay? Why do all this extra work? And in number 21, you can see that you can take out something that they have in common. You can take out the a's for each one. And when you do that, you're given, now you got a standard quadratic trinomial. And to factor it, we're going to look to find factors that multiply to 14, positive 14, and add to negative 9. And that would be negative 2 and negative 7. Right? Negative 2 and negative 7 is positive 14, negative 2 and negative 7 is negative 9. Set all three of them equal to 0 to find the actual solutions. So a would equal 0. Add 2 to both sides, a is 2. Add 7 to both sides, a is 7. There are your solutions. 3 of them. How do we know there would be 3? Because it's a cubed. Started with a cube, so it has to be 3 solutions. All right, 22. Now, one thing you're also supposed to know, besides taking on GCF, you're supposed to know that everything's got to be in standard form, and this is not in standard form the way it is. We're going to have to subtract the 3x squared over, set it equal to 0, and then we can solve. Once we do that, though, we're kind of back at number 21. We got to take out a GCF. We can take out an x squared from both terms. You're left with what? X minus 3. So x squared equals 0, and x minus 3 equals 0. Well, the x squared equals 0 is going to be 0. Add 3 to both sides for the x minus 3, and x is positive 3, right? So literally, x is 0 and 3, okay? All right, here we go. That's all we have time for today. So, thank you for showing up. Appreciate you being here. And remember, math, math, math. Get up and do some math.